Lesson 849, On or Off the Line, Interpreting Points on or off the line. In this lesson, we're going to introduce systems of equations, and the goal is to be able to identify and interpret points that satisfy two relationships at the same time using graphs. So I want to talk a little bit about the graph that's on screen now and give us some practice with graphing lines like we did a while ago in Unit 3. Let's talk about what we see in this graph so we can start talking about what's going to be in the second half of this unit, which are called systems of equations. You'll notice that I have two lines here instead of just one. And when we're talking about a system of equations, we're talking about comparing lots of different lines instead of just one. I've used something from the last lesson that we had, where we had one water tank that was filling up and one water tank that was draining. And we wanted to know when their volume would be the same. So let's look around at this graph for just a moment. The x-axis at the bottom represents the time in seconds. The y-axis on the side represents the volume in liters. And you'll see that for tank A, I have my line and an infinite number of solutions. I've just marked a few of them, but any point on that line is a solution to the equation that represents tank A. And what these numbers mean relate to the labels that we have for x on the bottom here and y on the side. So really, this solution, 7,235, means that in tank A, after 7 seconds, there will be 235 liters of water. In this next solution to this tank A after 12 seconds will have 385 liters of water. And this point is also on the line for tank A. After 19 and a half seconds, there will be 610 liters of water in tank A. I could do the same thing for tank B. It's the one that's draining. After 5 seconds, there's 900 liters. After 10 seconds, there's 800 liters. And there's an infinite number of solutions on that line, one of which is this same point that's on the red line for tank A. And that's what we're looking for in a system of equations. We're looking for the point that both lines share. In other words, for both tanks, after 19 and a half seconds, there will be 610 liters of water in each tank. So what we're going to do today is practice graphing some lines and finding that point where the lines intersect. We'll get back into real-life scenarios later, but today we're just going to have a review of graphing lines. We should begin our review of graphing lines with reminding ourselves of what the equation of a line is going to look like, y equals mx plus b, where the number in front of x represents the slope or the steepness of the line, the rise over the run, and the constant that's added on to the end of the equation represents the y-intercept. Here's the y-axis, and the y-intercept is where that line intersects the y-axis. So remembering this, let's take a look at what you're going to be doing for your assignment today, which is graphing some lines. This is going to be puzzle 161. I want to do the first one with you together, and then give you some tips for how to deal with some of the more difficult problems a little later. So you'll notice right away that we have two equations instead of just one to graph, because this is a system of equations. We have to have at least two. Let's identify the slope and the y-intercept of this first equation. The slope is the number in front of x. Just going to box that in here. And the y-intercept is the constant that's added or subtracted after it. And we can use those to graph a line. Let me get some graph paper. And show you how this works. To graph this line, I'm actually going to start with the y-intercept, since I know exactly where that point is. The y-intercept is at -1 on the y-axis. Here's the y-axis. Here's 1 down from the origin. And then to figure out what this line looks like, I'm going to use this slope, the rise and the run from this slope, to move on to a second point. I'm going to start here at the y-intercept, but then I'm going to rise 2 and run 3. There's 2, and there's 1, 2, 3. And you'll remember that this slope triangle, we have the rise of 2 and the run of 3. So here's a point on the line. That was my y-intercept. Here's a point on my line. That's what I found when I applied the slope. And we could do that again and again and again if we wanted to. But there's my line. Now, we've done that before. What we need to do is graph this other line and find out where it intersects the first one. So again, here's the slope. It's -1. And here's the y-intercept. It's 4. So on the same graph, let's graph this line. This was the y-intercept. Again, I'm going to start with the y-intercept since I know where that is. On the y-axis, I'm going to go up 1, 2, 3, 4. There's my y-intercept for the second line. And the slope is -1. So I'm going to go down 1 and to the right 1, because I know that a negative slope is going to decrease from left to right. I'm just going to continue going down 1 to the right 1, that same slope. And I see that eventually I run into my first line. And that point is the solution to the system. It's the point that both lines share. That's the point, let's see here. 1, 2, 3, 1. Those are the coordinates of the solution. So I'm just going to write that over here. And if you want to do the little puzzle and find the answer to the riddle, it asks you to cross off the box that contains the answer. So I'm going to find my answer down here, 3, 1, cross off that box. It's not part of the answer to the riddle. If you need to rewatch this part of the video to do numbers 2 and 3, then feel free to rewind and watch that again. But do numbers 2 and 3, and then come back when we get to number 4, because we're going to have to do a little bit of adjusting for that one. And I'll give you some tips on how to do it. Go ahead and pause the recording and complete numbers 2 and 3 before you return. Hopefully at this point you've completed numbers 2 and 3 and you've found those solutions. I know that you could do number 4 here. To graph this system of equations, our first equation has a slope of 2. And hopefully you remember that if there's nothing on the end, the y-intercept is just 0, just the origin. But for this equation, the easiest way for us to graph this is to make it look like y equals something. So I'm just going to take a moment to grab a sticky note and show you how to change this equation into something easier to work with. So, find my black pen. So here's the equation, x plus y equals 3. And I'm just going to solve that for y. I want to make this x disappear. So I'm going to use a balancing move and subtract x from both sides of that equation. On the left side of the equation, I'm just left with y. Let me bring down the equals sign. And so that it looks like y equals mx plus b, instead of 3 minus x, I'm going to write negative x plus 3. Now I can see that the slope is -1 and the y-intercept is 3. I'm just going to write my new equation right here. Y equals negative x plus 3. I just rearranged that one. So I'm going to cross that off so I'm not confused by it. And now I can just graph this one now that it's solved for y. The slope is -1 and the y-intercept is 3. So you might have to rearrange some equations as you're continuing along. For number 5, you're going to have to solve this one for y and this one for y. And I'm going to do one more because when we get to number 6 and some of the other ones, we might not just have to subtract a term. You might have to do a tiny bit more. So let me scooch over. So I'm going to help you with both of these equations so you can see what you'd need to do to make it look like y equals mx plus b. Let's start with the first one. Well, first of all, I'm going to move this y term to the left. If I want it to look like y equals mx plus b, I need y over here. So I have x plus 3y equals 3. And now I'm going to use another balancing move to move the x to the other side. Subtract x from both sides. I'm left with 3y equals negative x plus 3. Now I don't quite have this where I want it with y. I need to do one more thing. I need to divide everything by 3. These 3's cancel out. When I have a multi-term numerator, each term gets its own denominator. So this first term, negative x, really becomes negative 1/3 x. And this second term, 3, really becomes 3 divided by 3, or 1. So that's what I'm going to use for this equation. I'll write it to the right here in just a moment. And for the second equation, we have x plus 3y equals -6. Again, I want y on the left, but I want everything else on the other side of the equation. I'm going to write -x minus 6. So my x term comes first. Then I'm going to divide both sides by 3. This becomes negative 1/3 x. And then -6 divided by 3 is -2. So I'm going to graph that. Just going to take a moment and write what I changed these to. Y equals -1/3 x plus 1. And I changed this one to y equals -1/3 x minus 2. So you'll graph both of those. So this activity this puzzle will give you some practice again at graphing lines, which we're going to be seeing a lot of in this unit.